This is Gus Jansen at MATRIX Robotics, and this is going to be another one of our series of videos, tips and tricks videos on building with MATRIX. This video is about servos, how to build with servos, how to work them into your robot, how you can make your mechanical things around the servos work. Alright, the MATRIX comes with a servo kit, the MATRIX system, and the servo comes with a few parts besides the servo itself. The Servo Horn, the Servo Bracket to mount it in. It has these little connectors that I'm going to show you a little demo of on how to build with, as well as some small M3 shoulder screws and the accompanying washers, nuts, things like that. So, how to build a basic structure with the servos. The first thing you got to note of is the proper way of mounting the servo into the bracket. In order to be consistent with the MATRIX grid, so that everything fits in your model and so that the servo horn is positioned properly, you want to put the servo on top of the plate. If you put it underneath, you can do that, but it will throw things off. Normally you would use screws to secure the MATRIX to the servo plate, but in this case I'm using these white quick connectors. The quick connectors come in 3 different lengths. The white is the medium length. Normally it's perfect for connecting 3 layers of metal, but because the plastic flange on the servo is a little bit thicker, the white quick connectors are perfect for securing that servo to the servo plate. Alright. The most basic thing you got to know about using the servo and the servo horn is that this has a special spline shaft that the servo horn fits onto, and that servos have a certain limited range, and what you may need to do is position that servo to make it work for your particular model. So let me go ahead and add something to this servo horn so that we sort of feel like it has a purpose. I'm going to put a couple of quick connectors securing this 3x7 plate. I need to use the white ones again for that same reason, because the servo horn plastic one is a little bit thicker than the short one, the short quick connectors that are only good for 2 layers of metal. So now I've put a small plate on my horn. You can imagine something here, could be a little fork, some kind of a gripper, something that you want your servo to do in your model. And it has a certain range of motion. So you notice that it's sort of limited from this to way up here. Well, in my case, I want my servo to really be centered down that way, and it's not. So what I'm going to do is I'm going to find the center for the range of motion, and it's approximately there. It's the center of the range of motion. Now I'm going to pull the servo horn off, put it in the center where I want it to be. Now I can test again. So that's one extreme, that's the other extreme. So now I've positioned the servo horn exactly to get the range of motion that I want for my application of the servo. Once you've done that, you want to put the servo screw. It's a small black screw that also comes with the servo kit. You want to put that in, put it into the servo horn, and then use your Phillips style screwdriver to secure it. It doesn't have to be overly tightened, but it should go in there. Once you've got that on there, the servo horn won't come off. Very important. It's very tempting to just put the servo horn on there, not screw it on. You build a big robot, your servo horn comes loose, and then everything is thrown off. Bad things can happen. Make sure you get that servo screw in there. Alright, now, how do we build with it? In some cases, this may be adequate. Just building your device, your gripper, maybe you're kicking a ball or something like that. You don't need anything on the servo other than the servo arm attached to the horn. But let's say you want something a little stronger. You need some more strength to it. You don't want to rely entirely on just the servo horn, because it's the weak part. The servo spline shaft itself has limits to the strength. So if you have a great big thing that you're moving, it may not be such a good thing. May not be a good situation. What I'm going to do is I'm going to secure the servo bracket to a C channel, and I'm going to build a little structure around here. Use quick connectors. Normally when you build robots, you want things, it's good for prototyping with the quick connectors, but you really want to use the screws and nuts for strength. Now, before I put this on, I'm going to prepare something. Notice that if you were to look between this, where the pivot point is of the servo on this side, and where this plate comes in here. It will line up perfectly, but it's not the center hole, it's one hole down. So in that hole, I'm going to mount I'm going to use a screw. It's easier to do this before I put it into the structure. So, and again, it's not the center hole, it's one hole down on this flange plate that's kind of matching the servo plate. And then I'm going to tighten this up. And actually I'm using a nighlok. I'm using an 8mm M4 screw and a nighlok. And the thing that's important to note here is that when you tighten it up, you tighten it and then you back off a little bit, maybe a quarter turn, maybe a half a turn or so. Then this can turn freely. It's still kind of snug, it's not loose, but it can swing freely. If it doesn't turn freely, then you need to loosen that screw on that nighlok a little bit. And because the nighlok has that nylon insert, it won't work itself loose. Now I can go ahead and add this to my C channel. And I put it right behind my servo plate. And what I've done is set it up so that the rotation axis of the servo and this pivot point here, they match. And now I can put this across here. This is a 3x7 flange plate. And what's special here that you need to note is that the servo horn itself stays on module. So the surface here is going to be on that same grid with the holes that correspond to the servo plate. And the width, the distance from this surface of the horn to this plate back here is an exact integer number. So whatever it works out to be, 8 matrix unit, 8 times 8 millimeters, so 64 millimeters. That's why this fits perfectly. This is quite a bit stronger than just working off the servo, because now you have a pivot point over here. This thing moves very smoothly up and down. You can build a bigger structure on here, and the servo will work off of there. There are other ways of doing this. I'll cover very quickly. I'm going to take off what I've built here. Another way of doing this is I'm going to put, and which works best for you, kind of depends on your particular use of the servo. So before I had my sort of support plate on the opposite side from the servo. Now I'm going to do it on the Servo Horn side of the servo. Again, I'm using quick connectors. Normally when you do something like this, you would be working with screws and nuts. It's good to prototype with the quick connectors, but when you know exactly how you want it to be built, I would go with screws and nuts. They're much stronger. So this is really the same idea of what I just showed, except that I put the servo on one side, this matching support plate on the opposite side. I still am using a 8mm M4 screw with a nighlok nut as my pivot point. Here I have my servo actuator. This similar to the structure before. This is strong. It won't twist because it's got a pivot point there as well as the servo pivot point. Everything lines up perfectly. It's a good way of building with servos. One more sample I'm going to show. I'm going to use this servo, but I've pre-built most of the rest of it. How to build a very basic gripper using those connecting rods that come with the servo. Still have the servo on the servo plate. take off the horn because I already have a horn that I prepared. So here I'm actually building some things with the mechanical parts. Not exactly sure where my servo is positioned. Here, there we go. So here you see those connecting parts that come with the servo kit. I'm using them to open and close these gripper L-beams. And the servo turns one way, it closes it, and I turn it the other way, it opens it up. You can imagine this on the front of a robot. Here I have the D shaft going into the C channel to give the pivot points. You probably want to use collars or something so it doesn't fall off, but for this sample I don't have that. So this is good for when you're going to open and close. It's good to use these connecting rods. I'm going to show you one more. I'm going to show this servo in action on this robot right here. Go ahead and turn this on. This is a big complicated robot that does a lot of things, but one of the things it does is that it uses servos for this block grabbing mechanism. You go ahead and pick up a block. You can see that it's got one servo up on top for turning the gripper, and then it has another servo that opens and closes the block, the gripping mechanism, in a similar way to the gripper that I just showed you. This is actually a tic-tac-toe playing robot. So it put one block down on the board. You can't quite see the board, but you pretend that there's a board there. I'm going to go ahead and make one more move so you can get an idea what the robot does and how the servo mechanisms work. And now the robot would wait for another human player's turn. This is a video about servos. Servos are super useful in your robots, and build good robots. More information, go to matrixrobotics.com.